Good morning, everyone. Myself, Anurag. I part of Tenor. So, thank you for coming. This is in 2024, still in Kochi. We did an event in Trivandrum. So, welcome. How many of you are new to Tenor? Okay, great. So let me introduce Tamer. Tamer started as in Microsoft community group, community user group in uh, 2003, and there were a lot of other user groups like Kochi Microsoft user group was there, Kochi .NET user group was there, Calicut was there, Shivanda Microsoft user group. And in 2003, everything is merged and we formed Camer. Our website is camer.net and you can join a WhatsApp group. Let us know, me or Praveer. We can add you to that group. So we used to do events like every month. Every month, third or fourth Saturday, we used to do event like this. Next, we are planning 2 more events. In March, we are planning Global AI Bootcamp, and in April, we are planning Global Azure Bootcamp. Welcome all. Let me introduce the first speaker. He's Jithin. He's working in Software Solutions Private Limited. He's a senior developer there. He will be talking about .NET 9, sorry, .NET 8. Please. Thank you.
Good morning. So myself, my name is Jithin Sakthan, and I'm working as a full stack developer in Software Solutions Private Limited, and that is my colleague. So yeah, coming to .NET 8. So hope you are aware about the .NET series. .NET Core series is like 7, 6. Anyone new to .NET? What about .NET Core? So coming to .NET 8, I'm just talking about .NET 7. So mainly the Microsoft focus about the things like performance and yeah, we can talk about the performance actually. In .NET 7, comparing with the .NET 8, it ensured more performance-related aspects, and also some we can have the code-related aspects also there. Some Blazor-related aspects. They can introduce new Blazor web app, and for the actually we can talk about 3 things. One is the .NET Core, and one is Entity Framework, and the third one is C# 12. So in coming to the .NET 8, in all areas, many improvements are there. That means coming to the performance, they improved a lot, and coming to the Entity Framework, they introduce new things, and C# 12 also we have some amazing technologies. So yeah.
Depend.
Recording in progress.
Screen sharing will demo it. Screen sharing then window share करते हैं. So PPT मारो. Visual Studio करो. Oh, screen sharing. So screen first right?
Yeah, I'm already talking. These are the 3 points for the read. Add keyed singleton. So the field service actually, when we use for that, something like this purpose. That means when you use a same interface for different purposes. Okay, that is a method is different. Okay, so before it, we can actually using a inheritance method in .NET 7 and all. So, but in this .NET 8, you can create a keyed service like this. So the next is a cool feature like Blazor. Anyone using Blazor? This no. Okay, so head about Blazor. What is that actually?
App development.
Okay, so that development. Okay, no need of any other JavaScript frameworks for the front end aspects. So, for the coming to the Blazor web app, it is fully what we call useful for a full stack development. Before it not like that actually. So when coming to the Blazor web app, it is fully we can use like a full stack development. So you can create the methods or you can create the C# code inside the pages and you can incorporate the JavaScript inside the pages. All the things we can achieve through using a Blazor web app. So I just give a demo for how you can create a Blazor web app. When you create a Blazor web app, we can get this default things. You don't want that things, you can just check just empty web page. You can get these things. Not the edit that things are not getting now. It's only available in Visual Studio Preview. So I'm just showing without this that code operation. So we create, update, delete. When we create a project, it offers all these operations also.
You can mute your mic, like it's echoing.
It's already muted, but
No, on the Zoom. There might be a. There's a red dot if you see on the top. Your
they mute actually. Yeah. So coming to the Blazor web app, I just how we can see how we create a how can we create a web app in Visual Studio. We just search for a Blazor. So you can see lot of Blazor apps. So Blazor as WebAssembly app web assembly, then server app empty. These are the things we already have in .NET 7. But the Blazor web app is a newly introduced one. So we can select this. Just give a name. So when you select the framework, we can only get the .NET 8 latest version. Okay. So the server and other Blazor apps you can get the older frameworks. Okay. So we have some other configurations here, some WebAssembly server. So we can just use the server. It's actually related to the rendering mode. In Blazor, we have 2 or 3 types rendering modes based on the front-end and back-end communication actually. So that we can discuss after this. Just create. So when check on this checkbox, you can get the pages, some example pages also there. Otherwise, it's an empty book. So coming to the project structure, you have a www root and the component. The component is containing all the things like layout, pages, and that is a dot razor pages we need to run. We can create something like CSS HTML pages, but you can write the code inside that pages. You can write both .NET code as well script. So then this is the layout. You have the main layout. All the things are there actually. So then coming to the program.cs file. This is also the you can register your services and all the things here. Same as the .NET other applications. So when you run this, so it's a good project. When you create a Blazor project web app, so you can get these things. So then you want to add more navbars or menus and the pages. You can achieve that things. So that I just showed a demo how we can add the menu and all. So this is the navigation menu. So you can see all the menus here, home, weather. So just using this, using the href weather, that means that is a page name we use here. This is the weather, the counter. Okay, that's a dot razor pages. So when you click on the counter, you can see some code here. That means inside the HTML, you can give a trade code. You can give the C# code here, and you can give the methods, and you can call the methods something like this on click, something like same as the some framework in JavaScript, Angular, or so when we call this increment count, so it's here then current count. When we can print the variable here using @ what is the variable? Simple actually we can create a Blazor app. So if you want to add a page, there's a component. Check that. So in each page, forward that we can give the route at the right page, codes slash route name. So when you the domain slash the route, you can access that page. So I just give this page we can access that page using slash test. You can check that. Okay, so slash test, you can access that. Then if you add like a menu, just duplicate one. That is test. Okay, the test is there. Then you can when you click on the test to create a put that page. Actually, it is very simple. The Blazor web app development is very simple. You can achieve all the code related aspects, all the things combined with .NET. You can achieve all the things when using a Blazor web app. It's actually very what we can call so it's a simple thing. So this is the way we can create a Blazor web app in .NET 8. Then this I already told that the edit and the third option. When you create a web app, you can check when you need a CURD operations. So it will add all the edit, delete, all the things. So let's explore that. It's not available in this Visual Studio. It's only in preview. So yeah, that is called the Razer component using entity framework. That is a component when you choose, you can get these things. Then yeah, before that yeah, we need to aware of some render modes in Blazor. So you can notice that here in this code we have some render mode. Okay, that is interactive server. So when you are not giving this, the interaction from this code to the front end won't happen. Okay. So many types of render modes are there. You need to explore that. So I'll just mention when you create some, so that is actually different classifications are. When you want some interaction from the front end, you use interactive server. Some client server is there. So different things are there. And when you want to, there is no interaction between the server. You just dealing the front end part. You can remove that part, render mode part. So when you remove from this counter page, the button click won't happen. The counter not incremented. So in each page, actually, the home page, there is no render mode because there is no interaction from the backend end to the Blazor from the front end server. Actually. So there is a plain text or content we can just display. So we are not using any type of render modes.
Where is the style coming from? Style?
CSS.
Okay.
WP.
Okay.
Yeah.
So what is the best practice to embed the code along with the HTML or to separate the code and then basically do an include or something like that? You know, in JavaScript also we do similar now.
Yeah, actually, I don't know the best practice, but it's your requirement actually. So you want to communicate with if you want to add code in the page, you want to dealing with the front end, you should add that. That is a place the Razor syntax you can use. So
So instead of at code, is there an at import or something where I can import a snippet of code?
No, so basically you can create components.
Oh, okay.
We can import that.
Okay.
Like if you are use ASP.NET, there is a like user control. There is a concept like that. So it will be basically an UA with some code. You can reuse that if required.
See, because I don't know, I've not worked with the apps much actually, but if you see styling, logic, and then the display, which is basically the HTML portion. So these three are segregated and they are brought together at one time, you know, in some form or the other. But in your case, what I saw is that you have an HTML code beneath which you are saying at code and you are writing the logic there.
yeah, yes.
So basically now in the single file, I have both HTML and the logic associated to that HTML embedded there.
Yeah.
Okay.
Actually, that is I think the concept.
Yeah,
Okay.
every
Blazor.
JavaScript frameworks now works like that.
Oh, okay.
There is something else also, like when we have these raster pages, we can create a raster.cs page where we can write the code, I guess. Don't you remember that exactly?
And
Not aware of. Razor.cs.
Yeah, like when you have racer pages there.
Okay.
Similarly, yes, so you can extend it like racer.cs page. I'm not wrong.
in Razor pages it works, but Blazor I don't know. Razor pages we can do like that. There is a like project that called web app or Razor pages. Not MVC, Razor pages. In that it will work like that. But Blazor I don't know.
So yeah, that is all about .NET Core and Blazor and the key identities. Sorry, DI dependency injection.
Yeah, and then the dependency injection, what is that? Because that looked very complicated to me, because I have used Spring Framework in 2004 and all, you know.
Okay.
Dependency injection is a very straightforward process. You have an interface, you can have n number of implementation, and during runtime you ingest which you want to, you know.
Yeah.
Like simple case is mock. Mock classes are classic examples of mock implementations of your original code, I have a payment gateway. I want to pay $500. You will not really connect in testing time to the real payment gateway, you mock it out and stuff. But why was a key and all another,
So, in .NET Core, if you got a, like, implementation for same interface, two classes, then we had to do a lot of, hangama around that.
oh, okay.
But it would be an IAM module, you can be, you can add that, but then in the constructor, you would have, it will be a collection.
Yeah.
So, and then, yeah, you have to maybe write a factory. But by using key interface, we can just inject everything, and by using that key, we can take whatever we want. That otherwise we have to implement the factory. And then package out. Yeah.
Okay. I don't know, because Spring was the first framework which introduced dependency injection in way back actually, 2004 I am talking, So it's almost like 18 years. So at that time, it's basically a series of XML which, initially started with XML and then they brought into annotations actually. Because earlier these annotations was not there, but nevertheless, it was much more simpler than this.
Yeah.
I could ingest a implementation of a class very easily, I don't have to complicate the whole thing with the.
Yeah, like Spring and all still exists, but this is out of the box.
Oh.
If you want some other dependency injection like autopack or anything, you can use it. This comes out.
So is it maintaining some hash table of all the interfaces and all the keys associated to that interface or something internally?
Yes, like a service collection of things.
Okay. That makes sense.
Yeah, but in Spring, I guess like there's an option of auto app and
Yeah,
it's like a property
Yeah,
injection.
yeah.
Here it's like constructor injection study.
It's very intelligent. Yeah.
This is like out of the box kind, so we don't need any third party services or things.
So, the next thing is, entity framework. So, hope you are aware about this, entity framework, connections and all. So, coming to that, in each versions, they have some updations in entity framework. So in this .NET 8, basically, the performance and all the things, we have some certain points to, they are improving something in all areas. But we can't say all these things, but just we just take some of the examples. What are the improvements? What are the key things in entity framework 8? So one is the value object using complex types. Actually, the complex types is nothing much. When we you need to create or save a address type. So you just create maybe a class and give the address 1, address 2, city, country, all these things, right? So coming to the entity, you just mention that class and the address. Okay. So when the time of migration, so it should be what will be the actually output? It should be in 2 tables or 1 table. The address and all.
I did it.
Okay, so yeah, I will show that. So coming to this entity framework 8, the query is like that actually, but it saves in 1 table actually. So when you create a customer, just give an example. This is an example. That is the address. Sorry, yeah, this is the address part. Is a customer. So I just give the address type address. Then you create an object of that customer. Give the address whatever you want. Line number 1, city, mention all the things. Then just add that customer and save changes. That is basically using any different. So coming to the query, what is the back? It's happening backend. So insert into customer name, it's like address city. Then it denote like address city, address country, something like that. Okay. So that is the difference between the previous version and the current version actually. So
So what is the relationship between customer and address? Is it a one-to-one or a one-to-many
customer and
address?
one-to-one.
Ah. What happens if it is one-to-many?
That order. If you look at the code earlier, there was an order that was one to one. Can you go back?
Where?
No, not this. No,
Before
previous
that.
time was a list of, there was a list of orders. Can you see that customer?
Ah, okay.
But you have only get there.
Both is
No. Because, that orders, it's, there is only get. That is not
Oh.
getting set.
oh
So this is very similar to the object relational, yeah, Hibernate, classic example.
Yes. So,
Okay, okay.
so when you want to achieve this, you just mention the complex type when you create a address or something like that.
so we need to decorate that address class with complex type attribute.
Yeah, yes, as an attribute. Otherwise, when you create when the registering an entity, you can use inside the context, you can use something like this. Entity customer dot complex property. Mention that which one is the complex property. You can. These are the two ways. Yeah. Some breaking changes. I just mentioned that here. That contains in link query may stop working on older SQL versions. Actually, in we are all maybe all are using that contains right in link use. So maybe coming to the .NET 8, maybe it's not working actually from expected. Some other things are enums JSON stored as instead of string by default. Then SQL Server date and time now scaffold to .NET. Date only and time only. Many things are there. I just mentioned something here. So yeah, coming to C# 12. So also many features are there. So I'm just explaining one feature that is called a primary constructor. And some other features are the collection expression, default lambda expression. You just want to explore these things, just Google it, the Microsoft, all the documents actually, the release related aspects, .NET new frameworks based on the entity framework, C#, .NET Core. We can cover within a 1 hour session actually. So look into those things. So primary constructor is a small thing. So when you create a class, you all are aware about how you create a constructor, right? Just a class name, public class name. So then you can give the parameters and all. So coming to the primary constructor, when you create a class, instead of you can give the parameters. Okay, it's actually it's like a you can create a clean code using this. When you yeah, I will give an example actually. When you injecting the interfaces for the dependency injection, you can inject that into constructor and assign all the things into inside the constructor, right? With the local value. But in this case, you can just using the primary constructor instead of that, you just give that parameters here. That's all. Then you can use the parameters or objects inside the class. So there is no assigning all these things. Look, this one is the without using the normal constructor, you can declare the things, and inside the constructor you can assign those things. But coming to this you just give the parameters here. Actually, you won't use this, you can print those things, last name and first name, you can use the first name and last name. No need to do this also. That is the primary constructor, so. Yeah. That is from my side, so. These are the things, new things in .NET 8. We just search and look into those things, what are the things into, what are the things you can explore or incorporate into your code and get more performance or code optimized code you can create. Many things are there. So yeah, that's all.
What was the like foundation for the initially you said, when you create connections, you had read-write connection to database and read-only connection to database.
Yeah.
You had two contexts or something like that, no?
Yeah, that is actually when you create a DB context, you have save changes and all, right? So we can override that methods in the read. We no need the save changes, right? Okay, so you can use the read HTTP context for only that purpose. You can override that.
Because why I asked is, see, we have implemented sometime like long back actually. So basic idea is very simple. If you see any production system, 80 to 85% of the time it is read queries.
Oh, okay.
Less than 15% of the time only it is write queries. So what we at that time used to do is very simple. You have exactly similar to what you mentioned, but the difference is read write always goes to the master node. Read always goes to the slave node. See, because every time a database is set up, you have a master and you have a slave.
Okay.
Basically, because the reason is what happens if the primary crashes, So read queries are always routed to the slave, but they are synced up so fast that you will never see the difference actually, But the primary database only will accept write queries, And as soon as you write, that is replicated onto the slave, whatever name you call it, whether it's master, slave, or primary, secondary,
I think that is exactly the behind the microservices architecture also. Microservices architecture has polyglot persistence, right? You have two different databases.
Okay.
Based on what is the better. So you can have two different. So for read, maybe a NoSQL database is better than your relational database, but for a write, a relational database will be better. So polyglot persistence in a microservices architecture also caters to something.
No, here it is the same relational database.
Yeah, this is one thing also we need to in entity framework, we have some as no tracking. We can give that. So when the read operation, we are not doing that. So we can avoid that thing.
So basically, what happens if you're using entity framework, it comes with entity tracker. So if we change something, it will track, okay, that entity becomes dirty, and we can simply go save changes and it will save to
back. Yeah.
But if you are using, like you mentioned, if you want pulling a report, you don't need to, you have to track the entity.
Yeah.
So there is a notation like we can specify, okay, this entity we don't need to track.
Okay.
Also, we are using the same method. We are writing into it is a AWS RDS. So we are writing into master and we are reading from replica.
Okay.
So that's why we use two tier context.
Okay. Yeah, because that is something which we used to do like long back actually. Because of the reason that if you analyze most databases, less than 15% only write happens. It is actually 80-85% is always read. So the read should not block the write, and that is why the primary and secondary was always used in that form, such a way that write always happens to the primary, chip sync happens, and then you do the read. So you don't get a stale info, in your subject. Yeah. But I was curious why.
But our read is very much less.
Okay.
It's a
Mostly right.
Yeah.
Okay. Yeah.
What about the connection tool? Are there two different connection tools created when you are for read? There is different connections.
Yes.
We got two different connection strings
Yeah.
because RDS actually gives us one connection stream for.
Okay, right, we were creating it like that.
Yeah.
So is your connection string pointing to two different places?
Yes.
Or is it two
Yes.
single?
Yes.
Two. Okay.
Two streams.
Then I think it's the main same concept,
Yeah.
which is.
So this connection port is part of the Liquid now?
Yes,
Simply.
yeah, when we are creating a, when we are injecting database context, we can specify, okay, this is a pool. We can inject, like mentioned, you can put single DB context. You can put pool, you can even get into a factory. So you may have to manage the lifetime of that entity, database context.
We were using Postgres at the time, but we had a much more complex problem because we had what is called multi-master. Multi-master is a very complex setup where you have three masters for the overall globe, And what they do is when you write it in Asia, ultimately it will sync to the other two regions also. So your primary key always needs to be selected in such a way that you have a regional key, So you have one in your record in US, you will have one for the US region, Then you can have one and Asia region two,
Oh,
So multi-masters are always, nowadays it has become much more easier because internet was not of high speed those days. So database replication was a big problem, especially when you have multi-masters, Nowadays the internet is so fast that you will not realize it. Yeah, but
And most of the cloud providers, that doesn't work.
yeah, not only that, if you see today, Google, they have their own fiber. They don't go through Airtel or anybody else. So their data centers are all connected by their fiber. So it is all real time, like we are talking 20 millisecond, less than that type of a latency. But olden times it was not like that. You can have minutes latency also actually for transfer activity. Yeah.
Rajeev, how did you have the keys? Your regional keys were connected to your
Yeah,
primary keys.
Yeah, so always in any region you have a primary key combination which is let us say a sequence number followed by a regional key, because that regional key is what makes the record unique. So if US geography regional key is given as 1, Asia geography it is given as 2, and PRC China it is given as 3, that will never collide. So you can have 1, 1, 1, 2, 1, 3, So that means it is the first record created in all the three regions, Multi-masters are always a very complex problem to deal with.
I think even today it is valid. If you take hybrid cloud scenario, then it will still.
Yeah, you have, because primary key collision cannot be accepted. You need to design it in such a way that they don't collide, Yeah, interesting because some of the old problems are still surfacing,
okay, so thank you.
Thank you.
Okay. So, കുറച്ചുനേരം മലയാളം പറയുമ്പോൾ ഇംഗ്ലീഷ് മാത്രം അറിയാത്തവരുണ്ടോ? നോൺ മലയാളീസ് any non-Malayalis? Anyone? അപ്പോൾ മിക്സ് ചെയ്തു. Okay, fine. So start off with നമുക്ക് ഒരു സൈഡിൽ നിന്ന് തുടങ്ങാം. So എല്ലാവരും I think would have heard of frameworks, UI frameworks. Angular കേട്ടിട്ടുണ്ടാവും. കേട്ടോന്ന് പ്രതീക്ഷിക്കുന്നു. Angular it's there for a pretty long time. React അറിയാം. ഇത് അതുപോലുള്ള പുതിയൊരു അവതാരമാണ്. Svelte എന്നാണ് ശരിക്കുള്ള പേര്. UI framework ആണെന്നുണ്ടെങ്കിൽ കുറച്ചും കൂടി കൂട്ടി പിടിച്ചിട്ട് Next.js കേട്ടിട്ടുണ്ട് എല്ലാവരും. Next or next, NUXT or NEXT. So basically you can do അറിയാത്തവർക്ക് you can do the server side and the client side all together in one single application. So അതുവരെ ട്രൈ ചെയ്താണ് SvelteKit എന്ന് പറയുന്നത്. Okay. Spelling is like Svelte. So the basic idea is very simple. You can write the server side code and the client side code together in one single application and finish it off.
And everything will be on node.
Node plus micro. You can have Node plus JS, any combination. Combination is fine. That so another keyword to put together white, VITE, white. How many of you have heard about white? But a very common thing. It's a builder. So basically, like let's say if you take Angular, you had the browser builder right before. അതിന്റെ ഒരു ESM version ആണ്. ESM ഒന്നും കുറച്ചും കൂടെ like
V8 in the river.
അങ്ങനെ പറയാൻ പറ്റില്ല. So basically what happens there is that there is a transpiling happening for the JavaScript code into whatsoever is needed into pure CSS or JS and HTML, right? For every UI framework, that's how it works. So you write on something, it gets transformed to another thing, then it goes to the machine code. Okay, so to write this HTML, CSS, JavaScript part, we are using these compilers. Okay, so these basic compilers, now there are a lot of them. So to start off, you had a normal browser compiler. Now it comes like there is something called remix, roll up, roll down. So roll down is going to come right on top of Rust framework or Rust language. കുറെ അധികം ഉണ്ട് ഇങ്ങനത്തെ tools. Okay, so White is actually like a packaging tool. So White is an NPM package. NPM is not package manager end of the day. So White, if you install White, and then you will have an option to basically start off with Angular, React, WhatsApp. Angular out of the box, yeah. But you have React, Vue.js, and everything. So it is actually part of it. Now it's basically like there is something called Vercel, there is something called Netlify. They are packaging and paying for White and such package managers. So what this guy does is that they basically promote all these UI packages. Okay, and SvelteKit actually is a part of this White part. Whenever you install White, you have an option for React, Vue, and SvelteKit by default. And how many of you are here who love Angular? Anyone who love Angular? No one. Anyone who is still working with Angular? How many of you are still working with React? Still working still?
Still, I mean, all those.
Still like actually today, because I cannot be sure in this person. React in View. Okay. View like ഞാൻ പോകുന്നില്ല. I'm staying back from the View വന്നതും പോയതൊക്കെ ഉണ്ട് ഇല്ല എന്നൊരു stage ആണ്, to be really frank. So I am personally using Vue, React, SvelteKit, and Angular in my projects. Okay, so I don't know, maybe because I got over 30 now, I really like the MVC structure end of the day. My personal opinion. I don't like this new age stuff because end of the day it gets confusing when your project starts rolling. Once it goes beyond a stage, then either you have to make it like an MVC and make sure everything is put together. So what happens is that let's say you want to tell this to another person. Either they have to be really intelligent to understand how you write the code, or how you name things and everything like that, or you need a lot of documentation and it's messed up. But let's say you have something on real MVC, it's pretty easy. Like once they know the basic, then they will start learning it and they will go. They won't come asking back to you why this is like this, why this is like this. All these questions won't happen. So this happens when you're training with noobs and others. So that's what I have felt in my lifetime. So to start off with myself, Alok Rajasukumaran. So I have been in K1 from 2016, 17, 18, 19, 20. And 20 I left when the corona came and pushed me off. He didn't allow me to come back. Okay, now he's allowing me to come back. So it's been pretty long time on this stage. So I have been working in Orion for some time, 2 years. I'm an ex-Orionite working with private Nile lately. Okay. So right now I'm working as a Chief Technology Officer or Technical Officer at Advanced Intelligent Technology Services Private Limited. So it's a service-based company. And the very good part about it is that I'll be able to work with all these stupid things every day. So one person will come and tell, okay, I need this. You don't know what it is. I will make it and give it to him and he'll leave. Later he will come with back things and then it will be like, okay, the version has completely changed. The code is gone. We have to rewrite everything. So I hope someone actually raised your hand for React.js, right? How many of you have been working on React from somewhere around 2020 to 2023 or maybe 2018 to 2023? Is there anyone who have? I don't know. How many times you have rewrote? Have you ever rewrote your React code?
Yeah, so there are that's there, so we will come to that is here.
So this is the basic problem. Okay, so the very basic problem that we are dealing with all these languages, right? All these new age people is basically this. So especially React is very much. I don't know why they are doing it, but the next day they are introducing a new version of something. They'll ask us, okay, this is not going to work anymore. No backward compatibility. You write new thing. Especially with React router, I had like very recently when 5 to 6 actually happened for React router. Suddenly the routing stopped altogether. So they will basically just change the syntax. No controller is nothing. You have to go back to your documentation, read stuff, and then you are knowing, okay, you are an early adopter, so you have to do it yourself. Got it? That's basically happens with being an early adopter. Now, again, the contrast of Angular here again, because I am using Angular also. So I've been working on a project from Angular 11. So right now, 2-3 days back, we made it to 17.2.2, which is the latest version. 17.0 was there, 17.02 was there, 2.2 just now came. We just upgraded, nothing actually worked. The only code change we had to do was on angular.json file, where they introduced a new builder called ESM builder. I hope everyone know what is ESM, the new way how JavaScript is written. So the very basic reason was that I'll give you the build times. So that will give an idea. So development build time was around somewhere around, let's say you save a file, it used to take somewhere around 5 seconds to reload. So that heavy the project was. It actually drastically reduced to somewhere around 0.5 to 1 second. Now it's built on white. That's a major reason. So they changed the compiler. When you change it to ESM, it becomes a white compiler. So that was a bit fast. The build time was basically somewhere around 1.58 on our Jithin instance. So it's an 8-core 16 GB RAM machine that's doing the Jithin spot. It was 158. Drastically, it reduced down to 58 seconds. So there were some optimizations because there was many packages which was not ESM ready. So we had to make them ESM ready. We got rid of many packages we didn't need actually. Now the build time actually reduced to 58 seconds. And now when you are actually navigating from one page to another, you are able to know the speed difference. So I will just give you a glimpse about all these frameworks, all these web frameworks, right? How these things are working. You either have two ways. So earlier, let's say on the server client system, you had two ways where you click something, it will go back to the server, you get some data, it comes back, and it will reload to the front, right? It will load to the backwards to get from the server, then it comes back to the front to render the data. Now the new age frameworks, everything works like an SPA, single page application software. So what happens? All the JavaScript, HTML, CSS, you either load it on the globe, on the first load itself, or when you are actually navigating or you're hovering on something, it will load from the server and it will keep on working, right? I hope everyone knows what is a virtual DOM. Document object manipulation DOM basically means what you're seeing on the screen for your HTML script, right? Whatever your HTML structure is. Now, there are two people. Now, this is basically like caste system. Okay, so there are people who use virtual DOM. There are people who doesn't not use virtual DOM. Okay, so Angular, SvelteKit, these two people are basically working on DOM itself. Now, you React uses virtual DOM. Now, the very basic advantage of using virtual DOM is basically that the reload speeds when you're doing the dev is super fast. Let's say someone who is working on Angular goes down to Vue or React, he will be really mesmerized because he's changed something just directly happens. Let's say you're working with two screens, that's when it basically happens. Like you will be able to see the magic. You can do things fast. Bad part about things like Angular, sometimes you'll have to stop the program and again start it. Because let's say you work with something other than the normal page DOM structure. That's on the inner part, you come to the outer, on any of the basic structure of the application, you change something, add some package, it won't reload. On to when it comes to SvelteKit, let's say you add a package itself, it reloads. You don't have to worry, like you don't have to stop and start, it will automatically do that. So it's very advanced at that.
These are only a development perspective, right? What about?
No, I'm coming from the dev perspective. Okay, let's not talk about deployment part right now because that's very crazy. Okay, so
How, when you do your kit,
huh?
why do you think this is?
I am not really telling this is good. I am telling okay, gamer, there is something like this coming in the house, and this seems to be more like a complete package. So I know someone, I think you guys will also know someone who actually has built 4 projects on SvelteKit. He was telling that in Gamer, if you guys remember. He did 4 projects live on SvelteKit, it's working fine. Admin panels basically. So we are also tied in for one client. Let's say you know the boundaries really well. This is what you're going to build. This is the maximum extension for this application. Then this thing is really good. Being really good, I will tell you when I actually go down to the coding part and show you that part. So I think the problem here is that if I
No, just not minimize it. Can, no.
the thing is like if I actually go for the presentation mode, it's actually taking like 2 screens. I don't know why. So will the share happen?
Yeah, it's shared.
No, what I'm asking is like press this button. Now, is it being shared?
It's
Okay, great. Good. Now, what is Svelte? So Svelte is what the guy actually came up first. Now SvelteKit is basically that a UI framework. It's just a UI reactive framework that basically comes with a lot of components out of the box, where you can start building your application. That's all about Svelte, nothing huge. Okay, yet another UI framework. That's it. Okay. So if you want to read, it has navigation bar, HTML, CSS, JavaScript, all that stuff. There is a compiler who does the job and give you your HTML, CSS, JavaScript for the browser. That's what he's done. Now, when it comes to SvelteKit, they like to call it like a framework. So framework as in what it basically does is that it handles both client-side code as well as server-side code. Okay, both in the same particular project. So you don't need another set of node application, C# application or whatsoever. This is what you saw with Blazor also, if you remember. Like everyone is trying to do this. Okay, there is Blazor, there is SvelteKit, there is Next, there is NUXT Next. Everyone is there on this. Now, Svelte versus SvelteKit, it's very basic. One guy actually plays with only the UI component. The other guy tries to play with both UI as well as the server at the same time. Okay, that's the only thing. Now, people who have worked with React, you know, everything is actually separate. Even routing is another package altogether, right? Everything is actually different set of NPM packages. They will have their own documentation, their own updation, their own life cycle. So anything can happen anytime. Good part about Angular is basically that it's a framework. They release something, it's purely well tested. It won't break that easy like what happens with React. And Vue also, it's kind of like that. It's kind of stable. SvelteKit also is coming the same way because it's coming like a framework. What basically happens in routing, state management, and all of the basic things that's needed is taken care inside this particular package itself. So you don't need to install another time to an extent. Okay, that's where the deployment part comes, which you asked. And then I think I can go down. But you there? Okay. So the thing is, like, he has told me some small time break is needed. That's what I'm looking to. Okay, let's come down. So I told you guys about 2018 to 2023 about React, right? So I had a project on React Native. Okay, so we had a bad problem where React basically updated. So this was on peak of the corona time.
React Native is mobile.
It's on mobile. So there was a peak time of the corona. So basically what happened is very simple. React actually introduced a small change. So they got rid of many of the context and they renamed many things. So React was basically, I think it was on 0.68 to 0.70 version. When it comes to 0.70, most of our packages stopped working altogether. Like we just upgraded React version, the React version to 0.70 and nothing was building. So we started investigating what is happening. We were getting somewhere around 4K to 5K errors in our project. And when we actually dig deep down, then we found out that basically because of these context changes or the naming convention changes, all of the NPM packages we were using, including for buttons, star rating, everything as such started breaking. None of the packages was compliant with the new React. So this is a problem with the open source code. Or rather, that was when the corona was at the peak. That was the worst time we had, right? So the people were not ready or they were not having the time to come back and write. And I don't know, unfortunately, many people, when we actually went down, was not contributing for more than 4 to 6 months at least for many of the common, very popular packages. Or no idea why many didn't even write after that. So I hope they are not there anymore. And we ended up in a point where we had to either rewrite, remove all the components, write our own components, or we have to get a new component altogether. Now, this was the worst experience I had with the React stuff, with the React Native. So what we basically had to do is we actually stood on top of it and we tried to fix it. So there is something called patching. Let's say you have an NPM library, you have a feature called patching, where you can patch that library with your own code. Let's say they are not accepting your pull request and releasing it. You can patch it and you can release it on your simple application. I'm not telling to the NPM. Okay. Then what basically happens, your application, when that error comes, it will go and get the latest code from there. And it will work. Your stuff will work at least. We started patching. We worked for 3 weeks. We could only solve somewhere around 2K errors. Still there was somewhere around 2.9 errors. And we gave up. We gave up on all our application. And that's why something like SvelteKit was actually looking at us, which was at that time named as Flutter. We migrated the application altogether from React Native to Flutter. No, I'm telling about the new package. So a new package manager was basically looking forward, called Flutter. So Flutter was just booming up at that time. So we rewrote everything from React Native to Flutter. And we moved off. And that was the major last project we did on React Native. By that time, we crossed it. We started telling clients straightforward, we can't do this. Because this is actually a major issue where, let's say you are time bound, you want to do a release, and especially when there is a release for something like this thing, payment gateway, there is a major stuff to be done there, or there is something like they want a new feature which needs to use something on hardware, then you will be bound to do the updates. And once you're not able to do that, you cannot really push it forward. So that's the reason why I was actually not advocating React for some time now. So I had this bad experience. That recently I had even shared that to the Cayman group also. Like there has been people claiming the same for React also, React.js also. From 2018 to 2023, there has been at least 4 major breaking changes happening. So adapting with the breaking changes is easy for the program writer as such. But let's say the packages we are using, we cannot really give a timeline, how much time it will actually get updated. Now that's one major issue that we are having. So that's a major issue. No, we didn't have that much Flutter. So I will tell you why. When you're taking a package, there is an option to basically look at how many star rating, how many usage, how many stuff. That's the basic thing we do. Now, let's see what happens. Let's say you take Angular, for instance, or even Vue, for instance, okay, and Flutter, for instance. We could see there are people who are more serious about the packages. Serious, I think they are ready to do it, do the updates, get things done. And what basically happens with React, right? Starting with the basic thing, you're dependent to outside it. That's a major fault we are having. Now, it's a good as well as bad. Good is that if you don't need it, you don't have to use it. The bad is most of the time you will need it. As I said, told about the React router. So I have a very bad habit of updating the NPM packages all the time. I'm having that very, very bad habit. So every time I get time, especially at the time, I will go down, create a new branch, I'll try to update it. So this is a bad habit that I am personally having. So I don't know why. That's maybe too much of overprogramming or something like that. It's my fault. Okay. So this is the same thing I did with the app also. So there was something around 35 to 40 dependencies we updated, including all the Angular packages, but nothing actually broke. It usually doesn't break because it comes after the testing, right?
I mean, I know you're coming from experience and it's very good to hear, but just one thing, the way React sells itself, right? React Native or whatever, they sell saying that they have the highest community of people who are.
Exactly.
But even then,
It's a contrast there. See, the problem here is I'll put the problem down to the paper. Even to start with the routing or to the major small stuff, you have to be dependent on the React project. So that's what I told what happens with React Router 5 to 6. So the day I updated, it was not backward compatible or they haven't wrote the console errors. So I was an early adopter, like really early adopter. The moment it came, I was basically using the NPX, NPM U package manager to basically look for the updates. So I saw the update, I did the update. Okay. Now what basically happens at the moment it started break, then only I started thinking, okay, something is wrong. Then the next step is basically to unupgrade, do it backward and see whether it was all working. So it was all working. Then I went down to documentation and started reading. There was a small change. It was a very small change, so we had to do it. Okay, it's basically because you can write it anyway. Now that's the second point here. There is many ways to write React, right? There is many ways to write many of the packages out there, UI packages especially. You have many different ways how you can write this thing. So what basically happens is you are losing the standard there. Now the point you lose the standard, it comes down to this way, right? You may write things, it started working, some blog posts are telling it's right, maybe the documentation is also telling it's right, then you are actually going forward with it, right? Now the next year the documentation is telling you have to change it. That's the point when you realize, okay, once your project is actually really large, that's when you can't do the updates really fast. Now, why you have to do the updates fast is basically your own convention or maybe it's all depending.
basically
Right?
what you're saying is when you run with the React project, you need much more governance when it goes to production. Or the updates and other.
Yes,
compared
yes,
to-
because you won't know. See, the thing is like you are depending on many packages which are not really something that's directly governed by even React people. Even React framework itself right now moved, right? They moved out of their even official website and everything, they went out, right? So these things are actually happening. Now, that's why I was asking, is there anyone who has worked with Angular? Because I have been working with Angular JS 1.2, 1.4, 1.6. From that time, I'm working on top of it. I've never seen that happening though. So the problem here is, let's say, the same with Flutter. We are working with Flutter for the past 2-3 years now. Ideally, on every application that we are building in our firm, it's completely on Flutter right now. We are not even using native much. If there is something to be added on native, we'll use the native code. On top of it, Swift or Kotlin, but most of the other things you are writing on Flutter. We have now faced the same problem. And Flutter, we are updating even really fast. Flutter, you have to update fast. That's a the reverse part here. Let's say what happens in Flutter when you are running the dev itself, it will tell, okay, a new version is coming up. You need to update now, or else you can stop developing. That's how it is. Now, this is actually a way how developers are putting. So there was a recent project we actually acquired to do the development. So it's been development for around 2 years now. When we went down the Flutter version somewhere around 2, the current is actually 3 points something. It's still on 2. So we asked the developers why you're still on 2. So they are kind of fear. They're like, okay, we don't want to update it because many people are there. It may start breaking. But on our experience with Flutter, it never broke. Let's say you are actually updating on every version properly. It was working properly till date. We didn't had any problem where Flutter broke the same way as React. But React we usually get. Okay. So this is my experiences with React, Flutter, and let me tell you about Vue. Vue never break. I don't know why. Wait. Break like this. Okay. Okay. So we'll take a break then. Okay. Please continue when we are having the break.
So I'm working as a TA in Orion. And I will thank you all for coming. And I will Kemagli first session ആദ്യമായിട്ട് വരുന്ന കുറെ പേര് ഞാൻ കാണുന്നുണ്ട്. So I hope we'll meet again here. Every month we have Kemag. We'll meet again. നമുക്കൊരു ഫോട്ടോ എടുത്തിട്ട് ആ ഫോട്ടോ Kemag ഗ്രൂപ്പിൽ പ്രവീൺ സെൻഡ് ചെയ്ത് തരും. Okay, so can you all come here?
Even with you, we didn't had the problem. So now I hardly have something around 15 minutes more for my session, 15 to 20 minutes hardly. So we'll start off with SvelteKit. Okay, how things are working. So we have 2 ways. What I will do is that basically in there, if you look down to the documentation, it's very simple, straightforward. So there are 2 things I love about this particular documentation. One, it's damn simple. Second thing is that most of the Sakthan repeller or REPL code component. Like you don't have to go to Slack bits or wherever page load from. On the time you can see that running. So if you have any doubt, you can just play around there and understand how it's working and then go ahead. Now I'll do something. So this is the open source, right? Obviously, other than not any open source. But I will tell you why I don't like it. I don't know. Okay. So what I did here is basically ഞാനൊരു demo project ഇന്നലെ വെറുതെ കസ്റ്റമർ സ്റ്റാർട്ട് ചെയ്തിട്ടുണ്ട്. That's what I am having here. So do we have a very good internet? If we start off, there will be millions of MQ packages. Okay.
Project is here.
Okay.
He will turn on his mobile hotspot.
Okay. So I'll just take you guys to the very basics. Okay. I just started a new equation and I'm opening a new folder also. Now move to the format. So the very basic step of SvelteKit. Svelte and SvelteKit both works the same way, like NPM packages only. NPM yarn, PNPM, anything you can use end of the day. And you can see the basic difference and everything here. So so you can start with this particular thing. So create Svelte. That's the whole thing that you have to do. So whatever your application name is, so let's say name it as Kemag. And that's it. It will go install all the packages for you, which is essentially needed for you to work. Now, how many of you people have worked in white anytime? VIT, it's same like white. So it will start asking you questions. Okay, so you can tell what you do. You can tell whether you need a demo app, Jithin project, or a library project. Whichever you want, you can choose that. Let's say I'm going for a demo project. Next comes JavaScript or TypeScript.
See, that's the difference with your .NET app, something.
We have million vegetables. And we love it. So let's say I'm going with TypeScript because I don't want to get to JavaScript errors. Now this is basically a multiple choice question where you want to add or remove whatever you want. Let's say you want yes input for linking prettier. If you are a prettier guy, you can use that. Playwright for browser testing, it comes out of the box. avoiders for the unit testing, it's also come out of the box. Or if you want, you can try the preview. I'm just giving the ESLint only for now. Okay. And that's it. Right? The project part is created now. Okay. Now you have the dummy project. So I will quickly take you through what is happening here. Okay. So you have the basic packages on which is basically using white. So white is the guy who is doing the build as well as the development runtime, both. Okay. And if you check here for linting, the ESLint is added. So let's say if you have did it in a different way, let's say you ask for prettier and everything. For this particular project, I have asked for everything. So you'll be able to see all that is out there. So linting is prettier, formatter is there, test integration is there, test unit test is there. All of that has came out of the box. Okay. So now that would be the basic difference there. Second. This is my SvelteKit demo to the old project. This is my symbol project. Okay. Now you can see the dev dependency this guy is coming with him is only this much. There is some font packages, there is some SvelteKit packages. So you will be seeing this adapter also. I'll come to this adapter on a later stage. This is a very important part in SvelteKit. Okay. And then you can see there is white and basic TypeScript, the packages that's needed. That's it. Now going down, you have something called as SvelteKit document. This is the basic guy who does the config. So I hope everyone here would have worked with something called Tailwind CSS. Most of you guys would have. You have heard about this particular config file if you're adding Tailwind into any project, right? It's a same step. You need this config file, and that's where things actually start working. So there is a kit called adapter. I have been talking about this adapter for a pretty long time. So just keep that in mind. Okay. Now, if you see the basic syntax, you can see there is annotation from everywhere. There is at the right annotation part. There is import. Like you can see all the stuff coming in mixed out here. And if you go down to SRC, those there is two folders, SRC and static. Static is basically the static data, which you have to serve whenever the build happens. So that could be your robot.txt or any such files, which should not be touched, should be just transpiled into the build environment output. Okay. Now, when you go down to SRC, you have something called lib. Same like Flutter. Lib is where you store your images and all of the assets and stuff like that. ID. Okay. So lib is the folder for just to do that, the asset part. So let's leave apart the lib part. And then you have routes, and then you have an app.html. App.html is the entry point file, the basic HTML file where the user will land. Okay. Other than static, let's say you want to add something on the head for G tag, any such integration, you can do the head here, body here. You see there is a percentage stuff here, right? Percentage SvelteKit.assets, percentage SvelteKit.body. Now this is what the particular compiler looks to. Whenever it see this percentage stuff, it will know it is something that should be loaded from the Svelte package. Okay, now everything will be changed of this particular or this particular things as needed when the transpilation happens with the compiler. Okay. And to work with SvelteKit or Svelte, you obviously need to install its VS Code extension if you want to get the control plane and all of that things. Okay, by default it doesn't come out of the box. You need to install the extension. But let's say you install the project, it has the recommended package on the package and so on. It will automatically tell you with a pop-up, do you want to install? Just process, it will work. You don't have to go install manually. And app.d.ts, as you guys know, it's a types specification file for the SvelteKit. Okay. So you don't have to worry about that. Now comes the crazy part. If you look here, you can see plus layout, plus page, right? Now plus is a naming convention that has to be followed. Okay, so the way this guy works is pretty crazy. So let's go down to the documentation. Let's go down to maybe the project structure, which is what I have already explained to you. The routing and everything I already went over. Okay, the project files also we already covered. The web standards, basic fetch APIs, responses, everything comes out of the box. So you don't have to install anything for anything as such. Now routing. Routing. So the way the routing happens here is using folder structure. Okay, so you have the SRC. SRC is the place where everyone will come and land. Let's say you have a folder called about. So that becomes your web page /about. Okay. Inside that you have seen every file should have the plus sign. Anything that does not have plus sign, it basically means it's not a Svelte related file. It can be your library file, your extra dependency file, or you are trying to type something segmented. Anything you can do that way using TypeScript or JavaScript. Even let's say you selected the .ts file structure, you write a .js, it will work. you can now basically take the data from the .js. It's running out of the box. Now, let's say you have something like src/route/above. So your web page /above will be taken to that particular file inside that particular folder. There is nothing as such like a routing file. A routing is taken out of the box by itself. It has a good part, it has a bad part. Good part is basically that when you're writing small projects, it's not a huge problem, it's just on the fly. The bad part is basically that, let's say you have a slash, you want to start matching. Let's say you want to have a dynamic stuff where you are passing something like 3, 4, 5, 6, some numbers or integers, anything else. Sorry, numbers or strings or anything as such. Now comes in advanced routing method, something called matching. So I'll come to matching on a later stage. Okay. Now I'll go back to our default project. So there is two set of files. One is called plus layout.svelte. And then there is something called plus page.svelte. Okay. Plus layout, basically the project itself, no, layout is being taken care in this particular file. So this would be the outermost file. Okay. Now importing the header and everything, it's just done out of the. Now if you see, there is a header.svelte, it doesn't have a plus. The counter.svelte doesn't have a plus. I hope everyone would have worked with, like most people would have worked with React, right? It's basically how you do on React or Angular or anywhere. You just create a file like that. Let's say header.svelte. You have a script, you have this stuff, you have the style. You don't need to import export. I repeat, you don't need to import export. It's being taken care of by default. So it's automatically by default exported. Now on any file you go down, you write that particular thing, you click on this, it will automatically get imported. Okay, so most of the bootstrapping or most of the conventional code you write on other frameworks, you don't have to repeat that here. It's something like by default, this is the way. Okay. Now the header is here. You have the app, you have the style. Styling, again, you can do style.css, you can write inline, you can do the React way, have the style down there. You can use any such needed, like whichever you're comfortable with, you can do that. If you want to go something like SCSS or something like that, let's say you're coming from Angular or some other framework where you're using SCSS, SAS, SLS or something like that, you will need its compiler. It's not really out of the box. I couldn't see that out of the box. So you will have to obviously install the compiler and get it done. Okay. Now that's about the styling part. And the footer, as you see, it's basically a component, but you're not having that component here. It's just the basic HTML system. The F is small. It's not a capital. It's not on blue line. It's on pink, which basically means it's just something that's okay. But the header, if you see, it's a component. Okay.
What about that slope? Is a external tag?
It's just a small. So I think this is actually an internal tag. This slot one. Even I was thinking about this main slot. So that's where actually the play happens. Now let's say this slot, right? Into this particular thing only, this particular page.svelte is being loaded. That's what I could understand. So this, all this stuff, whatever I'm doing is actually going off the, this gets imported. Now, if you see here, you can see the import.
Something like app component.
It's similar, like concept of the
difference.
Which one?
So
No, it's not. So this particular guy, I couldn't see anywhere declared. Even on the documentation, it's not clear. Even I was actually looking as I'm just said, why this particular keyword is there, but it's not clickable. I cannot see it anywhere. So as far as I can understand, if you don't, nothing works. So that's the reason I told you. It's the guy who actually gets injected. So that's where it's actually going into the layout. Okay. So now onto the script, you can see I'm doing the basic imports here, whichever is needed onto the basic page.svelte. Now let me explain you one single thing. There is a plus page.svelte. There is a page.ts. So page.ts is a file that does the TypeScript part of. So someone was asking where to write the code on place of page, right? This is the place on this particular type. Okay. Now you can create something called plus page.server.ts. Now that would be the server file. Who does the server side part of that particular page. Now when it comes to the rendering part. Okay. So routing we already spoke, and when it comes to rendering part or loading data, this is where that magic happens. You have two places. One, you have a page.ts inside a folder, which basically means whatever that folder name is, that particular folder's data will be coming from the page.ts. Okay, or sorry, the page.svelte. And you have a page.ts who does the TypeScript part for the page.svelte. So HTML is on the svelte, TS is on the .ts file. Let's say you want to write some calls onto that particular thing. You want an API to work.
Google started working. I don't know. It is understandable.
ഞങ്ങളുടെ മൈൻഡ് വോയിസ് പറഞ്ഞാണ്.
Okay. Okay, then I'll again come down. So let's come down to the about folder, right? So if you see here, you have a plus page dot svelte. This is the HTML. Dot .ts is where you can write the supporting TypeScript functions for that particular page. Now let's say you want to call an API from this particular page. And it's only exposed on this particular page. You can write that using a plus page dot server dot ts. Okay, and that's where everything will sit down. Now there is two set of rendering ways here because see what happens with all these major SPAs, right? I'll come down to that. So most of the SPAs when it initially came, it was basically that you write a lot of code, you get that on the server, you compile it to HTML, CSS, JavaScript, you transpile all of that to the client on one go. That was the initial thing. Then we realized that okay, the application JavaScript is becoming really large, right? With the packages and everything. Now what we basically did there is that we started something called SSR or SST, server-side rendering, server-side generation, static page generation, all of that things, right? Svelte comes out of the box with server-side rendering and generation. Now server-side rendering and generation is two different things. Server-side rendering is basically that, let's say you go click something, it will go to the server, get that data and come back. Generation is basically that on the build time, all the HTML, CSS, JavaScript will be built, okay, with all the combinations possible, and then it will get transferred. These are the two differences there. So in order to do that only, we basically use the plus Svelte server here. So for this particular page, when it's actually using the server's files has to be there. Now what happens, let's say you want to fetch a DB data for this particular page. You will be writing db.connect on that particular place, and you will be getting the data. And you have two methods. You can either tell this can load without the server load, or this can load only with the server load. Now, that's basically with the loading part. $page data. Now, this is where that basically comes from. So you can tell either to load this when the page actually loads, or you can tell, okay, load it only when you are requested. The same way like ng on init, ng on mount, ng on all that stuff on Angular, or with the use, I forgot the React part. Use something with the React, right, to get the data. All of that is there out of the box. And clicking and all of that actions come with on, call it, whatever the action means, load, click, whatsoever. And you can call the functions. So it works that way, okay? Now, there is differences when you're writing the universal or server. So there are basic differences. Let's say you are writing for static generation, okay? The way you have to write is a bit different. You will have seen that if you have wrote such pages. If you are writing for static, not generation, but only rendering, the way is kind of different, okay? So that has to be taken care by the documentation. You have to basically know when you're writing the functions like that, the DB calls, or let's say the business logics, okay? And the basic stuff, the form actions is already there. State management comes out of the box. That's next part. You don't need to install a state manager. It's there out of the box. Okay, it's not for you. So I can show you that here on the counter. So if you see, there is a count, okay? And this count is being taken up here, and then you will have buttons to plus it or minus it, okay? I hope this is already installed and I can start. That's one thing I love about white. It's just loads really fast. Now, if you see this particular thing, I can show you some certain things here, okay? So if you go down to the network, let's say we're keeping it open here. Now, if you quickly see, the moment I go to about, you saw that, right? The page is actually being called in the back, and you can see it here, .page.ts, .page.set. The moment I actually hover on the next one, the files for that is actually loaded. Next one, it is actually loaded. Now I come back, it's already there. Okay, so that's how the basic works. This is not static generation or static rendering, but the basic way how it works is like this. Whenever it needs the file, it will go and fetch it and come. Not when you click.
Is it not same in Angular?
No. Angular, most of the time you will load most of the time, or you have lazy loading, you will do that on the click. It's not on the hover. Hover, I have never seen it working that way.
Is it just lazy loading and again when you go back to about it won't load again?
One time it's loaded still. The problem with Angular recently that I faced, when you have the lazy loading happens after the main load. The main loading is done, it will go and load all the lazy stuff. But here it happens when it's actually needed. The same goes with Blazor. Blazor also fundamentally what happens when you need it only that guy goes and picks it further. So this is because these frameworks sound like SSR or security by default. If you work with Next or NUXT, this is how that frameworks works, the way it works.
If what it really does, is it just the
No, you can
just page scripting or
Yeah.
the content as well? Because in
The-
big applications, it could be huge data.
Obviously. So the page.ts file, what you have wrote on the TS, that's out here. And the page.svelt, if you see, the whole code is here. Everything transparent.
Including data?
Obviously. You're
That's
writing
going
it
to be
right
a problem.
there. You do that on Angular without this.
Yeah, that's my point.
Yeah, but this is faster.
Hmm.
Because like, if you take the Angular way, I can put it down this way. Most of the admin applications we do comes around somewhere around 6 to 12 MB. Okay, let's say on this particular thing, when we did the admin panel, what happens is that good part is that you hover, it comes. Bad part is that you have a network latency, it doesn't come. It has good as well as bad at the same time. So what happens? You click, you saw the loading now, right? On the documentation. It was supposed to load when I hovered, but it didn't. When I clicked, the network was slow. I have started seeing the loader. Okay, now that's the good and bad about it. Okay, so they're trying to make it better. But let's say I do something like a SSG, server-side generation, and I kept the HTML and everything already ready. Then this won't be there. Everything will come on the first go itself, and it will keep on working. There won't be any loading at all. Okay. Now the basic classic example of counter, this guy works. Now this is using the state management here. And if you can see, I'm just having a display count and I'm just setting the count here. So this is coming out of the box, the state management part. And post the state management. Now comes the crazy part. I think my time is going up. So I'll go to the build and deploy. Now that's where things get crazy. There are many ways to do this thing. Okay, let's say you work with Next, NUXT or SvelteKit. The ways you can do the build is different. How many of you have heard about Vercel or Netlify, such tools? So these things are built on top of funding as well as stuff from these people. So what happens? This is coming out of the works for this thing. Okay. Now let's say you want to do it yourself. Let's say you want to run it as a node server, or you want to do the static server generation. The ways are completely different. So for each one of them, you have particular npm package. And whichever you want to install it. That's what is adapter, which I spoke about in the starting. Okay. So let's say like, so this particular project, if you see down here on the app dot, not on the app dot, adapter. If you see, I have simply called adapter. But the by default adapter is basically called adapter-auto. Now the auto tries to take care of any sort of building by itself. Now how does it do that? So building your app, you have something called adapters. You have this much adapters by default. Cloudflare, Workflow, Netlify, Node, Static, Vercel. So let's say you're using Node, Vercel, Cloud, and all of that stuff. You can directly integrate that here. You can even deploy the stuff from here itself, from the command line. So you don't have to do anything. You put in the credentials, you put in the adapter, it will take care of it. Okay. Now comes the poor people's part. Let's say you want to run the Node way or the static way. You want to take control of everything. Okay. Now you have to use separate router for that, or the adapter first. Now you have to install that particular thing. Node adapter does not have anything to do much. You just have to install it. You run the npm run build. You will get two folders. One is basically the .SvelteKit folder. One is basically the build folder. Now again, this resembles me of a bit of rhythm rather than other languages. So like, let's say you go down, you have the server folder, you have all the files here. Now there is some certain things you need to take care of yourself, which does not come out of the box. Let's say you want to deploy this code. You have to take the package.json, package log.json from this particular folder, then take the build folder, put it together, take it to your server, then do npm mine. Got it? And when you're doing that, you have a command to not take the dev. You have a particular command for that. You just type in the command, then it won't install the dev dependencies. It will only install the normal dependencies. So there is a difference between normal dependencies versus dev dependencies. I know, I don't know how many of you know that. Dev dependencies are dependencies that are needed only for the development environment. The normal dependencies are the one you want for every time. If you are installing a dev dependency, you can mention that using -dev or -d, all that stuff. Okay. Now you will need to use that command. And then you can put in any of your CI/CD stuff to do it. And then you have to basically then node start, then it will start work. That's how it works. Okay. So the good part about this, you have a project with a boundary, you know how it's going to grow, where it is actually going. It's just let's say I actually use this guy only for admin panels. That's the most place I see you can do without much issues. Lot of data entry and stuff like that. You can do that really good here. Bad part is that let's say you want to do a lot of things. This is just a new thing. I don't recommend. To be really frank. Okay, this is just a new guy out there. Now Svelte 5 has came up. SvelteKit 5 has came up. It's just on preview right now. Community is small. Adapters is small. You have to be careful when you're using it. But hobby projects, it works fine. Normal admin panel projects also, no much issues out there because everything is out there on this guy. Okay. I have worked only with Svelte 4 till now. I haven't worked with Svelte 3. I haven't worked with Svelte 5 also. So I don't know if any breaking changes will come when you do the update. Now we have to be very cautious and tell all this when I'm introducing something. That's how the step is. Okay. So to summarize, the basic folder structure, you have the lib where you keep things, routes, routing folder name comes up the stuff. You have the advanced routing for anything like, let's say you want dynamic page selection with slashes and all those stuff, you can do that. It will be using the basic matching. So let's say you give about /ABC, it will go to the ABC folder. You try with DEF without a folder, it will try to match. ABC is string, it will go to ABC. Okay, it won't give error page. Now let's say you want that to be dynamically done, you can do that. Now that will happen automatically. You don't have a manual control. Now that's a crazy part. You don't have a manual control. It will happen automatically. So you have to be understanding the concepts here when you're developing pages for SvelteKit. Okay, because you don't have the route, you don't have any such controls. It works. There is a documentation for that particularly called matching. Hello, advanced routing. So these are the ones. It's using basic regex. It will match the page names. So let's say you are trying to do something like what is it about yes, something like this. You will get the parameter and then you can play around with the parameter. And you have the option to give something like equal to integer, equal to string to basically get rid of all the usual issues. You don't want string to come, you can basically mention that here. The basic will be taken care of there, and from there you can do that. And then there is something called sorting. This will be very much needed when you start working with advanced ways. You will have to sort it however you want. So the default sorting comes out this way. Okay. So multiple routes will be matched. So based on the routes, you can play around. So you can define it yourself. Okay, by using your brain. So that's kind of with SvelteKit, and this is one question that usually happens. I don't know how many of you thought about this. Let's say you put in any such symbols. Because you don't have a way to give the routing path, right? You want to use with the Linux and Windows file system, many of the characters won't be supported by default. So you will have to use the Unicode ones for that. Okay, the encoding Unicode ones has to be given, and you can use the character code and then do the string, and you can basically do this. You see here, using Unicode, you will be able to do the route matching like this. Okay, to any symbols, anything and such, any Unicode character, you will be able to do that. Okay, and that's about it. That's about SvelteKit.
Basically, anyone who React the learning curve is very less.
Yes, someone who is coming from React, Next, NUXT, and Vue, learning curve is really less. Someone coming from Angular, learning curve is really high because you haven't went to the React way, then you will start like why all this. Someone coming from React, it's really easy. Okay, because you are getting rid of the routing, which is a basic attack you have. You don't have to write a lot of junk code by yourself. Most of that is taken care of. But the good part here is the documentation is pretty simple. It only has the basics you want. So you can basically work on top of that and do this. So to the server side, I didn't show the server side, but on the server side, we are using SQLize, we are using Typeform right now. Everything is working out of the box without any issues. Okay, we are not using server side generation right now, not even SSR. We are using only dynamic client rendering now to be very precise there. Because let's say when you start using the other guy, you are using ORMs and packages, everything has to be raster, right? That won't be possible. Okay, you will have issues there. And even with that, let's say you're trying to, so I showed you the adapter, right? When you're taking the build, you're having a particular code block that's not server side ready, it will show the error. And it will show you how you can fix it. Many you can do, many you can't. Because it's not possible to do that on server side generation, most of the time. Okay. So any doubts, anyone? Anything I need to clarify? Yes. To be really frank, I stopped talking about this thing. I can maybe tell about Angular's future to an extent for React and Vue, but I cannot really tell for all these new packages because there is hundreds coming every day, thousands going back. And things are actually evolving this way and then coming down, then again going up. So we can't tell the future to be really precise.
So you said you worked on a project, about that and what and how this helped.
It was an admin panel. It was basically an admin panel.
Why did you choose this?
So to be very precise, I got a client who was working on SvelteKit. He was working for a pretty long time. We found it really good. Okay. We wanted to do the project on React. So that's what we wanted to start with, but we found this to be better than that. Better in the sense like, especially with the state management, to be very precise. Okay, you don't have to write the regex, you don't have to write a lot of gen codes for the state management. So state management was the first thing. The reason why we went for SvelteKit was basically because if you're choosing Angular, the reload time on the dev time. The dev reload is really high. Except like last Friday when I updated to 72, it was taking a lot of time for the page to reload on every single developer change. Svelte basically handles it the React way, even with normal DOM, not with virtual DOM. It only lazy loads that particular component. That was the second thing. Third thing was basically because I had a lot of developers with me who knew the other side, that basically the Node side, but they didn't know much about the HTML side. They know basic HTML, CSS, JavaScript, but they don't know React, State, and all of that stupid stuff. So I wanted to convert my Node people into full stack and get this done. So at that point, in this particular framework, they don't want to know much. Because it's kind of like MVC, you create a folder, you create the file, it works. You don't have to know routing, you don't have to know state management, you are getting rid of all of that. Let's say I want to take them to Angular, I need to talk or teach them a lot of basics, including MVC. Here, I don't want to do that. You get the learning curve change, someone coming from Node.js or not TypeScript, it's pretty easy to adapt. And it's very easy to tell them also. You have a file, you have a UI, you want to write an API for that, you write that on page server.ts. Done. It's straightforward. And even the good part is that let's say you have this is big screen. So let's say the good part here is that you have a file, you have a particular API for that particular thing to write that there. And for that particular thing, you don't have to write a lot of state management or a lot of gen code. Okay, it's pretty straightforward. So even what happens there is that I told you about, there is a load server, load on client. So on the click, you can call that particular API or even just refer that particular variable on the server file. You don't have to call a function. You just have to refer that, it will automatically go call the DB and get the data. So it's straightforward. You don't have much issues. But the issues we face is with the deployment. Deployment, you have to be very careful because you need to know all of that stuff, how things are working, then only you can do the deployment well.
So on the deployment side, one like Angular and all, we deploy in Astra Globe and all, right? Similar we can do here.
Node one, you take the node out, then basically it's just node run. Even with so anywhere you are doing any SSR SSG, right? Everything you are doing basically with node run. Or not start or not run tab or whatsoever command, right? The same way you can do here. The bad part is you have to do the transpile. So I talk about package log packages. Let's say you're using like Tailwind or anything as such. You have to copy that config. You won't really think of that out of the box. But if you haven't did that, it's not transpile. You have to do that. SESS also I noted it down. SESS, you have to do the transpile. You have to make sure it has been transpiled to normal CSS and only it will go. Okay. So anyone?
And since you did the admin panel and all, is it comes with some charting library or something like no? So what about like normally in Angular we use some Angular compatible React libraries. So that kind of ecosystem is here.
Not really. We created all the components. See, charges for charting. That's what we did. We were using it. So if you dig down to most of the libraries that out there for charting, everyone is using charges. So they are just tiling out of a Crime or MUI. Everyone is using them. Okay, everyone has charges. They'll do the extra stuff. So we did that, and we didn't have much chart also. To be very precise, we had Excel exports. We had Excel imports. That's being taken care by the normal NPM packages. Okay. Then we had most of the data. That's what I said. I knew the compound of my application very well. That's the reason why I went for the new type. If I didn't know the compound, if I wanted a lot of fancy UIs, I may not choose it. I may go for React or Angular with Prime React or Prime Angular because that's more easier. Right? I have everything out of the box. Any more questions, anyone? Thank you.
They are never stable actually, because there is a term called LTS, long-term support. If you ever understand it, a lot of open source technologies do not support actually LTS. Some has, but not all of them actually. And the second thing was on the optimization side. How do you write codes which are very efficient? And this problem is very prominent for machine learning because among all computations, whether you take web development, you take database stuff, you take other areas, computational cost of machine learning is much higher than all these type of things. Hosting a website which can access 1,000 people, the amount of computation required versus the amount of computation required to run a machine learning model is actually very different actually. And hence this technique of optimization is actually a very critical component. So think about your mobile where you want to load a machine learning model, you can't load large models in your mobile because they have hardly 6 GB or 8 GB of RAM. They don't have. But if you take a Llama 2 7 billion model, which is it is around 36 GB in size. And today 7 billion and all is considered small. If you look at some of the latest one, they are in into terabyte, trillion models type of things we are getting there actually. So optimization becomes a core component for that. So when you do optimization, there is quite a few areas to watch out for. So there are process, ML stages, what are the softwares involved, what are the hardwares involved, because these optimization techniques are very specific to hardware. So how do I optimize a machine learning model for Apple iPhones or something like Android, or if I'm deploying to an x86 architecture, or if I'm deploying to a graphics card? Actually, they are not very same. Actually, there are a lot of things which are very specific to the hardware that comes into this picture. Deployment types, profiling. I'll probably touch upon all those, and goal. Why the goal is at the center. Because performance optimization has different meaning to different people. So if you look at the goal, typically, if you see batch systems, I want to achieve higher throughput. So what is the higher throughput? Let us say I have a laptop, I'm running a machine learning model, I want to achieve, let us say it can process 30 frames per second. I'm running through a video, I'm doing 30 frames per second speed. I want higher throughput means ultimately I need to use the same hardware and I get 50 frames per second, or lower latency. Lower latency is case where either they are transactional systems or streaming systems where somebody is waiting for an answer, So you are on a chatbot. You type the question. You don't want to wait for long time, isn't it? You want the answer to come pretty fast. So the latency becomes critical. Pretty fast, you should respond back, Then cost reduction. For some people, they deal with billions and billions of images or videos, For them, cost is very critical because they want to process the video at the lowest cost possible, What is the type of hardware I use? What is the type of optimization I use to basically ensure that my total cost of ownership is least, Cost is a critical concern for everybody, Especially I always, I'm not a big fan of cloud actually, even though cloud is very popular. They always say, everybody likes cloud till you get the bill, So basically, ultimately, cost matters a lot in every field of that. Power reduction, especially edge devices. Edge devices like your mobile. You don't want a very powerful model to run. The reason is that it will drain your battery. Some models, when you run, actually, your battery will not stay more than an hour. Typically, all our mobiles, we will get 8 hours or 10 hours of battery life, isn't it? But if you are not careful enough, and if you drop certain machine learning models, that battery can come down to an hour, hours of time, because that's where optimization matters a lot. Performance per watt. This is predominantly a comparison with respect to human brain actually, because there are new architectures coming which says all the current computer architectures are very power hungry. So how do you reduce them so that you consume more like human? Humans consume very less. If you understand, humans are in the range of 5 watts. Whereas if you take a graphics card, they are in the range of 350 watts. Some of the powerful ones are in the range of 700 watts. So you can think how a human brain works actually. It's so low power that it does the computation. Higher core utilization, lower memory. So that goal is very important because how do you optimize? Because this question needs to be first answered in order to come to the type of optimization you want to apply actually. So if you look at an ML stack, it is actually it's a layered stack. Just like any other system, you have top. You want to do a business. You want to build a business solution. Your business solution could be very simple. You want to build a chatbot which could explain all the products you have. Let's say a banking website. You go to any banking website, either ICICI, SB or something, it has a chatbot. What are some of your questions? First is there could be questions which can happen when you are not logged in, which could be simple things. What type of credit card can I get? Or what type of account do you allow, type of things where you don't need to log in. But if you are logged into the site and now the chatbot could even answer things like, what is my balance at present? I don't have to go into the lower levels of that, or when is my next loan payment pending, things like that, amount and things like that. So business solution forms the top. Then the developer side of it, where you choose a programming language, you have an integrated development environment. You have few more tools which are available. One is the profiler. I will come to a profiler called VTune. When you run a machine learning model in your laptop or any hardware, how much of consumption it has with respect to the hardware, there's a lot to understand that. And then the machine learning topology, the frameworks you use, I don't know if you work in machine learning, but TensorFlow, PyTorch, or for standard algorithms, you could use scikit-learn, or specialized frameworks like OpenVINO. If you are deploying onto Intel hardware, they have a very optimized framework called OpenVINO. I think Apple also has its own framework called MLX or something, which is very specific to that vendor, You could use TensorFlow or PyTorch, which could work on any hardware. But if you want more hardware accelerated frameworks, like during runtime inference, if you are in Intel, you will use something like OpenVINO. If you are in Apple, you will use their framework, But it doesn't stop you from deploying the same code to run on a PyTorch on Apple, but it will not be much optimized. It will run, but the question comes is, optimization, and then the serving stuff. Then the compilers. So many times, we always program at the higher level language. See, computers doesn't understand anything beyond zeros or ones. Ultimately, how higher your programming language is, there is so much of abstraction that basically converts all this stuff into the lower level binaries, ultimately that runs. Actually, in this case, there's a lot of graph compilers which understand the mathematical functions that are being used behind the machine learning models, and then see which are the optimization, where can I apply parallelism, So graph compilers are a big field by itself actually. So anything from here and below that you are seeing actually falls into what is called system programming, because most of us are application programmers, isn't it? We deal at a programming language at an application level, but anything beneath this actually falls under the system side of it. So people who develop, hardware like chips and stuff, tend to be more at the bottom layer of this actually, and all the way like precision, what type of a hardware it runs on, silicon, runs on. So there are different silicon possibilities that you have and things like that. In my experience, India is reasonably strong in the top side of it, but normally India is little bit, India as a country actually is little bit weak in the system side of it. So if you see a lot of this core stuff written, you could see countries like China is strong, Russia is strong. There are countries like where the core mathematical functions, optimizations, route optimizations, all those things are done actually. So here you will see MKL, like math kernel library, very optimized functions for Fourier transform, matrix multiplication and things like that, which are actually behind the scene used in the machine learning models actually. And this is the precision. what type of a precision I do, and what type of a hardware I deploy, you know.
Is that country culture depends on the manufacturing of?
Yeah. Actually, it is very close to manufacturing associated. Countries which are very strong in like chip manufacturing and stuff have a very strong ecosystem for. It might change in India because now we are slowly setting up the 28 nanometer and 40 nanometer fab in Gujarat. I think the first one is going to come up. So once that comes up, basically the system starts slowly itself. So some small countries, you will be surprised, things like Poland, you know. You might not even think where do these guys come, because but they're very strong in the system side programming actually. So I don't know how many of you know, so data parallel C++, you know, DPC++, and there are specifications like SQL, you know, what is called writing programs which can be deployed into heterogeneous hardwares. So heterogeneous hardware is, let us say, if you take the latest Intel system like a 14th generation Intel Ultra Core, it has actually 3 to 4 different chips. It follows what is called a chiplet design. So chiplet design is a case where it has a series of chips actually. So you have CPUs which are basically x86 based, because Intel is actually an x86 based company. Then you have an SoC, system on chip, on that actually, which is what is called NPU, which is neural processing unit, very specialized for certain type of function. Chiplet. Yeah, chiplet design. So then you have integrated graphics, IGPU. So which is basically used for acceleration of videos and other things, you know, for that actually. So in a system like that, when you are running a machine learning workload, the question comes is, where should my machine learning run actually, you know? Should it run on my CPU? It can run on your CPU, but then the question is speed. You know, should I run on my integrated graphics, or should it run on my NPU, you know, neural processing unit? So typically there is something called offload that happens, you know, and this is where the programming languages like GPC++ comes into picture, where I write a single C++ program, but which has certain intelligent enough to basically offload into the right accelerator in your system, and that changes from system to system, you know. Now, when it comes to Apple ecosystem, they have their own toolkits actually. So some of these tools are very specific. So I don't know if you have heard of OpenMP and all, you know. So if you ever have worked on heterogeneous hardware stuff, actually you will get into this type of stuff actually. So this is what I always say is, very rarely I have seen India ever coming into the picture in the first 30 or 50 countries in the world in this space actually. That is because we lost the manufacturing of chips and stuff. So countries like Taiwan, you know, they have a very strong ecosystem, even though it's a very small country, you know. Yeah, so now let us go into the process and stuff. So typically in any machine learning pipeline, you have 4 stages actually. You have a pre-processing, you have a training stage where you train a model, then you do the inference, which is the deployment of it, and then you do post-processing to see how it is doing. Because none of the machine learning models are very static. They have to be constantly evaluated, retrained actually. So just like a human is, just like the way you and we learn new things and adapt to new conditions, machine learning models are also like that. They need to be, you can't develop one model and think that it will work 50 years. No, it will not work. It has to be constantly retrained for new cases. So an end-to-end performance optimization involves all these steps of pre-processing, training, inference, and post-processing, you know. So very important. Now coming to the software, as I said, there are very optimized libraries, but these libraries are very specific to hardware which you use. So here I have given you certain examples of Intel optimized libraries, because I predominantly work with Intel hardware. But if you are in NVIDIA, you use CUDA and others, you know, CUDA, or if you are using Apple, you use their own ecosystem like MLX and others, you know, they have their own frameworks to do that. So as I said, performance is always a very hardware specific concept, and you need to use the tools which that company gives you. Otherwise, what will happen is, as I said, you can use a framework like PyTorch or TensorFlow, but that will work equally well in all of them, but it will be not the most efficient option you have. No? So some simple things you can do to accelerate. Let us say if you were to take, PyTorch, you take PyTorch. PyTorch has an extension called Intel extension for PyTorch. So typically, if you tend to install that package and use certain changes which are requested by them, that same PyTorch code, machine learning code, can run much faster on your hardware actually. So it is, as a developer, it is very important, especially when you are deploying large machine learning models across huge systems, to understand this concept, because even a 10% improvement is very important. Let us say you have a farm which has 100 machines. If you were to get a 10% improvement, you are reducing that 100 machines to 90 machines. Think about the cloud cost that you will basically save if 90 machines. So let us say typically you took a basic machine which was 60 cents per hour. So in a day, 24 hours, 24 into 60 cents into 100, So you can see, if you were to cut down 10 or 20% of those machines to do the same thing with 80 machines, you are saving a lot of money, to do that, I think. So there are quite a few things. I can't get into this because it's a 1 hour session, but you can do lot, even scikit-learn and all, you can do scikit-learn Intel extension. It is a patch onto that main library, because what has happened is some of these libraries like scikit-learn was written long back when multi-core systems was very less. Most of the laptops had 1 or 2 cores. But today, how many cores do your laptop has? Most of them have a quad core or a more bigger than that. If you use gaming laptop and all, it is like a Intel Ultra 14. It comes with 22 cores, So if you write a program which is only using 1 core, what is the other 21 cores sitting and doing? Doing nothing. So that is what performance optimization is all about.
So I see this distribution for Python.
Yeah.
So that's a recombined version, right?
Yeah. This is the Intel has its own. So if you are distributing to the Intel hardware, you could use the Intel.
It's not like an add of it.
Yeah. All this, most of the companies are free. There's no cost involved. But it is the knowledge. It is the knowledge that people miss. So yeah, there are quite a few like that actually. I'm not going to go through, even including Apache Spark. If you are using Apache Spark, actually the Spark could internally use math kernel library, provided you are using Apache Spark MLlib machine learning library, or there's something called H2O sprinkling water, So if you are using H2O type of thing, just by recompiling your package with math kernel library, you can easily sometimes get like 40–50% improvement on your same pipeline, which is not small actually. So I've given some examples here, but nevertheless you can take a look at it. And then there are specialized libraries like Intel Neural Compressor, which is a very specialized library to implement certain concepts like quantization, pruning, the knowledge distillation. I'll touch upon some of those things actually. So as I said, pipelines are very different. It is hardware specific. See how a CPU approach looks like and how a graphics approach looks like. If you have a graphics card and if you run, see, why is NVIDIA so popular? Do you know the market capitalization of NVIDIA? Where does it stand in the world in terms of market capitalization? It's actually now almost close to second. It is the third spot. It is going to replace. It's already moved Google out of it. And if you know NVIDIA, it is a very small company which has a 2 trillion market capitalization. If you understand what is 2 trillion, it is more than the entire our stock exchange put together. Tata by itself, Tata is the largest, Tata and Reliance forms around $700 billion in market capitalization in India. This single company is, what do they make? Just graphics cards, which are accelerated. That's all they make. Simple graphics card which comes in your machines, Think about a company of that type of a size, because acceleration is becoming very critical factor, because machine learning, as I said, computationally developing web UI, deploying it or databases or things, if you compare that to machine learning computation, the amount of power machine learning consumes is huge. So now there is a lot of effort to see how that can be brought down, over a period of time, So now let us look at the hardware. So I'll quickly touch upon because we have very little. As I said, there are different architectures. So in my laptop, I have a CPU and I have an integrated graphics card. I don't have a discrete graphics card. My home laptop, I have a discrete graphics card because it's a gaming laptop, So CPU itself, there are different architectures. x86 and AMD also follows a more or less an x86 architecture. And then you have two new families, ARM and RISC-V, they are also CPU based. So basic difference is here very powerful, but it consumes a lot of power. So what is our mobiles made of in this? ARM, isn't it? Because they are more efficient core. So that's where you will hear terms called P core and E core, performant core and efficient core. So typically x86 falls into the performant core. They are very performant oriented, but the problem with them is that they consume so much of power. So when power is consumed so much, what will happen? Heat. That is why it is not that we can't build a mobile with x86 architecture. But if you talk like 20 minutes, you can basically fry an omelette on that, that will be the heat. So new architectures like ARM and RISC-V comes to that type of a. So Apple was actually a big Intel customer once upon a time, but Apple moved on to ARM actually, So they manufacture their own chips actually because Intel was not willing to move out for the performance because Intel makes some of the best. Along with AMD, if you look at some of the most powerful gaming laptops and stuff, it still comes from Intel actually. But the market segment was not big enough actually because mobile took over. They missed this board actually. They have ARM architectures, but not that. Then you have graphics, again integrated graphics and discrete graphics. Both are two. So in a chiplet design, what I said, actually it is, if you look at the motherboard, you have a series of few of these things together to form the chiplet design. But what is the problem with that? Software wise, it complicates because now I need to understand what is the available stuff and then I need to offload based on the respective hardware, that is where it becomes more complicated. How do I offload my machine learning model onto a graphics card type of a thing? And then you have FPGAs. We don't normally work at that, but very powerful, especially if you want very low latency type of things, field programmable gate arrays and ASICs and SoCs actually, ASIC is typical classic example is if you ever heard of tensor processing unit, you might be using Google Colab, isn't it? Google Colab allows you to either run on the CPU or to run on the TPU or to run on the discrete graphics, isn't it? So it's up to you. If you run on the basic version, you don't have to pay for it. But if you want an accelerator like a discrete graphics or if you want a TPU, you need to pay for it, If not, so it's basically the performance side of it.
Do we have any RISC-V example?
Which one?
RISC-V. Do we have any common one for example?
Common RISC-V is there are a lot of SoC based stuff used. I don't think like a mobile or something I've seen. Mobile, if you see the entire desktop and other things, x86 captures that. Server side also x86 is very strong. ARM is slowly getting into the server side, but ARM is more powerful on the mobile and others. RISC-V is the latest actually. Again, its power comes from the low power consumption and other things. Because see, if you want a mobile chip on a drone, which is flying around, do you think it can consume a lot of power? No, it can't consume a lot of power because the reason is the drone by itself is flying during it is eating the battery. Now, if you have deployed a intelligent machine learning model, it should consume as less and actually, if you see Ukraine-Russia war, if you have ever watched that, they use a lot of drones. Ukraine has it is very difficult to understand how Ukraine withstood 2 years of Russian assault, because Russia is almost like 10 to 15 times more powerful, both in terms of its everything, army, navy, everything compared. But these guys use technology to solve the problem, because ultimately in those type of drones, when you are deploying, those machine learning models should only consume very little power. So very important what type of an architecture you choose there and stuff. So here we have different options. They all have different capabilities. So this is general purpose. So that is why we use anything you can run. This is specialized. GPUs are very much specialized because they are used only for a very specific purpose. That's why ASIC and all falls in that. And then you have FPGAs also a different app. So it's not that one hardware architecture is superior to another. There are certain type of, it is more like how we buy a car, isn't it? When we buy a car for a small family, the cost, the compactness, others matters. For us a person, some people who have a lot of money, they want a 7-seater. Even though one guy will be going, still you will use a 7-seater. What is the problem? It will consume like gas, like it will give you like a 6-kilometer mileage on a stuff, whereas a regular car could give you 18 miles for that, So each architecture has certain strengths and certain weaknesses actually, It's not that one is superior over that. I'm not going to go through very detailed about that, but typically you could see some of the descriptions, flexible general purpose processing units. Whereas if you have a workload which could be parallelized, GPUs are very strong. And the reason is that they were designed for graphics, but they were finally adapted for AI actually. They were not designed for AI. So now, I don't know how many of you recently saw a new company called Grok, GROQ. They have a new chip called LPU, which is considered to be 10 times faster than this guy itself. So NVIDIA also will have its own competition. The market is very big. And then if you want very configurable type of things and very low latency, you do that, and custom logic design for ASIC. ASIC chips are they are designed for a purpose. So if you design it for machine learning, only machine learning will run in that, nothing else can run that actually. And then you have ultra low power and other things like TPUs, like stuff. This is if you look at the CPU family here, I've just put some of the families. So Intel Xeon forms the server side of it. So data center, So there are scalable processors. There are different generations like Skylake, Cascade Lake, Ice Lake, Sapphire Rapids, Emerald Rapids type of things. It comes with different capabilities. This is the desktop family. Desktop, like what we use, things like that, And then they have some very efficient processors for more like robotics and others, like atom-based processors and stuff which are very low power consuming and so if you are developing a robot or things like or something like cameras, So there are certain cameras like we have seen the AI camera and all, isn't it? Which Kerala government has done. So they will be using low power devices to do that type of a thing. So there are different and then embedded systems which consume further low processor. So if you see the amount of power it has and the amount of energy it consumes, the highest will be this side because it's all deployed on the server side, Then little lower, this will be the lowest side of it, in terms of consumption. Type of a thing actually. So this is the CPU family. I will skip this actually quickly for lack of time. So now coming to the deployment architecture, there are 4 deployments which are typically possible. One is, as I said, batch deployment, where nobody is waiting for an answer. So when you upload a video into YouTube, lot of things happen. They are not only storing your video, they are actually extracting the metadata out of your video, So that's why you say you have a problem. Nowadays, if you have ever watched the video, it will tell you watch from 1 minute to 1.5 minutes, isn't it? So how is it knowing that you need to watch from 1 minute to 1.5 minutes to solve your problem? Because it has extracted the metadata out of it to say that this is a 10-minute video, don't waste your time. What you are asking, I know where it is present, because that metadata is actually used to say that you should only watch that. So that is the case where actually a classic case of a batch deployment. 1 million people are uploading videos. It is all metadata being extracted slowly sidewise, and then that is basically sent to the index. So next time you search, I have so and so issue, it will bring in the video, it will tell you watch from point A to point B, So that type of a deployment is where throughput is actually the critical. Nobody is waiting for an answer. It will automatically come, but at that time, the maximum throughput is what you want to achieve. Then the real-time deployment, This is our transactional systems. Like they showed you how do you connect your UI with a database, So that is a transactional system. So let us say, in which case you were storing certain images and they were calling a machine learning model from either Angular or something, At which time you might be waiting for an answer, When you upload an image, it might say the quality of the image do not meet. I don't know if you have ever applied for passports or something. You upload an image, it might tell you like that, your face is not large enough for this to be accepted, But how is it understanding? Because it is taking your face and seeing the face forms 60% of the entire image. If it is not forming 60% of the image, it is telling that it is not a close enough photo of your stuff, So you need to adjust to that type of a thing, real time. Streaming is a classic case where you are getting a continuous stream, sensor-based data. So sensor-based data means a ship is going and it is streaming the parameters real time onto that, which is being analyzed, or vehicles are being analyzed. And then the edge deployment, which we talked about, a classic case of mobiles and other things actually, do that. So here power is very, very important. Power consumption is extremely important that we optimize that. So I will probably, so this is the application profiling snapshot. So I used you can actually download this tool. It is called VTune. You could profile any application. It is not machine learning application alone actually. You could even profile a regular Python application. So this gives you a core. So when this is run, so it is telling you that the overall time it took to complete this stuff was 720 seconds. How was the physical core utilization? How is the memory stored? How is the vectorization happening? And within that, so this is the unoptimized. After optimization, see, this is the same thing. How much have my time come down? My time has come down by 1/3, more than 1/3, isn't it? So now the same program which took 720 seconds is now running in 196.5 seconds after optimization. And if you look at that, you might think, why is the physical core utilization has come? If it is to run faster, it should have used more physical cores. No, sometimes you have to understand. That is where you have to understand in many of the von Neumann architectures, more time is wasted in moving data between memory and your processor rather than doing the processing itself. So this is very important. That's why new computer architectures are a little different actually to do that. See, a lot of things has improved, but my time also has come down, And then it gives you certain other parameters. Probably this itself is a big session, because how do you understand how your program utilizes the hardware? It doesn't matter what program it is. Even though I used it for AI, you could use the same tool for analyzing your program for other purposes also. So here it gives you, so it says you have 48 physical core in your system. So whatever is that, I was running it on a server, that's why it had 48 physical core. But if I run it on my laptop, it will say you have 8 cores, 8 or 4 cores depending on your laptop. What it says is that on an average you are using 43.22. So you are using almost decent enough, when your program was running. And then you have,
Is this tool free?
yeah, you can just download Intel VTune. It will install. It will work both on Linux and Windows. I don't think it might work on Apple, but I know it might still work actually ARM based also, but I think I'm not sure. And then it is talking about the stalls, cache stall, DRAM stall, and NUMA comes cases where you have multi-socket systems, So you have, so systems are sometimes, in a die, you have multi-socket means one socket has 24 cores, another socket has 24 cores. So that is how this system is made. That is how 48 physical core comes. Now, 48 physical core doesn't come in one single die. It comes in 2 dies actually. So what is the problem? It has its own associated memory. So if the core in this processor tries to read the memory from the other side, it has a higher latency actually. It's not that it can't read, it will read, but it's more like going to another place and coming back. So that is what is called non-uniform memory access, which typically comes up in multi-socket systems actually, and there are quite a few. And then vectorization is a case where even though CPUs are designed for sequential computing, they can do parallel computing just like a GPU, but not at the power of a GPU, but at a lower level. It is called what is called advanced vector extension, AVX. You might have, if you have ever seen AVX. And within the vectorization, it is telling SP stands for single precision floating point. So any computation that runs with FP32 basically is that. And what type of vectorization? This is double precision, non-FP is integer based computation, and this is the resident memory, I will skip quickly because of lack of time. So I want to show you some experiment which we done. So I did a neural architecture search. So 20 trials, each trial doing 3 epochs. So I was running a machine learning model to understand what is the neural network architecture that was doing. So concurrency 1. Concurrency 1 means if I have 60 experiments, each of them is done sequential, One is done, second is done, and then you go 60 times, So it took 801 seconds. So it told me that physical core utilization was not, I'm not using the machine well. So what is that I could adjust? I could adjust the concurrency to 2 to say that instead of doing 1 at a time, doing sequential, do 2 at a time, isn't it? So I changed the concurrency. What you saw that? Did it improve? It has improved because it has come down from 801 seconds to 566 seconds, and did the physical core utilization improve? It did improve actually. So it has now become 86.8. So am I utilizing well as I have target? Typically in any system, if you are using above 80% most of the time, you consider that to be ideally used system, You are not underutilizing, you are actually really utilizing well. And other parameters look fine. So now the question comes is, I'm very curious, can I further squeeze the machine, So I tried squeezing the machine further. I made concurrency 3. What happened to the time now? Went down. This is exactly what happens in our traffic. When there is a congestion, some guy will come and try to overtake, thinking that he is smart. But do you think he is smart? No, because he is causing the entire bottleneck to increase. And that is exactly what you saw. Look at the difference. A concurrency of 2 from 566 seconds, the same experiment now is taking more than 10 times. Am I doing anything more? No, I'm still doing the 20 into 3 trials. But what I changed is whether I should do 2, 1 when I was doing, I was underutilizing the system. 2, I got to a real optimal, but I had some capacity left in the system. By doing 3, I was trying to see whether I could take that capacity out, But see the experiment, what it has showed you. So sometimes this is very, very important in real-time large deployments. You should neither underutilize your system, nor you should overutilize, because overutilization can become very big problem actually. So when you take a cloud instance like a VM in Azure or something, you should actually profile your application to see, should I take a 4 vCPU machine or a 8 vCPU machine? Sometimes you take 8, you might be underutilizing the system a lot, but you will still paying for it. Whether you use it or not doesn't matter. The cloud provider is going to charge you for the hours you are consuming it, whether you used it is immaterial to them, So, see, I did 4. Now, once 3 is done, now it will increase. So 4 will further increase, So classic case of how a profiler can really help you, because even though I used it for machine learning, you could use it for your own workloads. It doesn't matter actually. And now comes the core mathematics of how do you take a machine learning model and then basically optimize it. Now, quite a few things. I can't go through each. I have a notebook for each of them. How do you do this in a real setting? How do you take a machine learning? But classic example is the first is the quantization concept. So the most common concept is what is called quantization. So if you have seen, typically we have precisions, isn't it, in our. So FP32 is typically machine learning all uses FP32 as the precision. But I could bring down that FP32 precision into FP60, bfloat 16, int 8, int 4. So how much computation is required if I were to convert an FP32 into int 4? Theoretically, what is the ratio? If FP32 was 4 bytes, int 4 is half a byte, isn't it? It is 8 times. So quantization is a technique where you convert a larger precision numbers into smaller precision numbers to do that. Finally, what does neural network has? It has a weight, isn't it? It has a bunch of weight. But how do I store that weight is the question mark. I can store it in double precision also if I want. But the question is it really adding any value to me? Answer is no. And actually quantization is the technique that uses. So if you take a Llama 2 model, 7 billion parameter, in FP32, it is around 26 GB on your hard disk. That same model, if you quantize it into an int 4, it is around 3.9 GB. So 3.9 GB is sufficient enough to basically load onto your laptop and others. But if it is 26 GB, you need a more RAM based, you need a very powerful, because what is in hard disk, that will blot to almost 1.5 times. So 26 GB will blot to 1.5 times means like around 40 GB. So you need a RAM in that range. But by quantizing the model, I'm bringing down to 4 GB. Now, even if it blots by 1.5 times, I need a 8 GB machine, to do that.
The same performance?
Yeah.
Actually playing around with it.
Yeah, more or less. There will be slight accuracy losses, but nevertheless, most of the time it is sufficient enough to do practical things. Yeah, that is how most of the models are loaded in low precision on your mobiles and all. Mobile and all will not load in the high precision, but that will consume a lot of power. This is why companies like Apple and all has dedicated team which takes a machine learning model, compresses it by 200 times. So 200 time compression means you have a 2 GB model, that will get converted into 1 megabyte, which is very sufficient to load it into the mobile and work through that, And then areas like pruning. Pruning is basically neural network is a set of connections, just like how human brains are, neurons are connected. They cut down the connections which are not adding value and make them zero, So pruning. Low rank approximation is basically a technique called singular value decomposition. So how do you decompose a large matrix into sub matrices? I don't know. Mathematically, there is a notebook. Let me see if I can do that. We'll come back to that. Knowledge distillation, parameter sharing. Now, quite a few techniques. Some of them are mathematics oriented. There are toolkits to do this. Actually, they are specialized. It's a very specialized field. Not too many people are into this field actually. So there is a set of process to do that, and there are some references. So these are the 5 techniques which are most commonly used. I talked about quantization. I talked about pruning, where you cut the weights. You trim the weights which are not required. It happens in our human brain also.
That's mostly this domain based, right? For pruning, you will need to have the domain knowledge of what weights you have to cut from.
Yeah, you will evaluate. You will evaluate your model as you prune and then see how it is behaving, and do that. Neural architecture search is case where how do you identify more efficient architectures, to do that. And then knowledge distillation is a technique called you have a large model. What you do is that you create a smaller replica of that, actually with less number of stuff, and it is called actually parent teacher. So how does a teacher student actually? So how does a teacher's knowledge can be passed on to a student who is much smaller in size actually, that is the technique called knowledge distillation. This is a very important technique, the first one, which is called low rank approximation. So if you know the metrics, if I have a 300 by 300, let's say if I have a million by million matrix, I can convert that million by million matrix into million by 50, 50 by 50, 50 by million, which will be, if you multiply, you will still get the million by million. But the reduced matrix, if you compute, it will be much smaller in size. A technique called singular value decomposition. I will stop it. There are more materials. I will stop it at that because it's a very specialized field. Unless you work on it, you will not understand it actually. But a lot of things happen behind the scene actually. So let me quickly just show you. Let me see if I have had some notepad. So okay. So this is the, I think this is the case for okay. So this image is the original image. This is the low rank approximation of that, which is equal to k is equal to 50. So what you did is, if you really look at this image, what was its original dimension? Its original dimension is 600 by 960 by 3. That means total elements is 1 lakh, 17 lakh 28,000 actually, Now you divide, you basically convert this matrix into a sub series of matrix, and then you get. So after which conversion, you are see the size and look at the ratio, which is 10%. So this is the original image. This is the 10% of this image. But for a task, are you not able to determine the left right side is also an and? So in order to do a classification, it is able to do at the cost of how much reduction? 90% reduction, to do that. There are so many examples like that. So that is how it is done actually, Yeah, I will stop here unless you have any questions. There are quite a few. I have notebooks for each of them. It takes time to run through that because this by itself could be a 6 to 8 hour session actually. It is that involved. But basic concept you have to understand. Ultimately, if you are into a machine learning project, you are deploying that, please tend to use these type of techniques to ensure that you are efficiently deploying your stuff, so that you don't consume too much power, you don't consume too much memory, compute, all those things. And very, very important in large scale deployments, because it indirectly impacts your cost. And especially if you are a small startup who is working with large scale deployment and stuff, you have to be very careful because you will get a huge bill at the end of the day. And even a reduction of 40–50% actually directly comes to your infrastructure cost and stuff. Yeah, I will stop it here actually. Very specialized field, but ultimately performance matters a lot actually. And people like me does this on a daily basis actually. So I have done optimizations in the range of 50 to 60x. So what was taking initially, if it was taking 600 seconds to complete something, we have been, if you get a 60x, you are now able to do what was taking 600 seconds into 10 seconds. That is the type of efficiency you bring in with the same hardware. You don't change the hardware here. You don't throw more hardware because that is not the purpose of optimization. To throw more hardware, it is always easy to do that. It is to get the same thing to work efficiently on the stuff. I don't know whether you have any questions because it's a very odd topic by itself, and not too many people does it also actually. Yeah, thank you.
Thank you, sir. Thank you. Now, this is something, which happens every month. So most probably it will be last, third Saturday of every month. So next 2 months, we will have a themed event, which is boot camp. See, one will be, it's 2 sessions. The first one will be AI boot camp. So which will happen here itself. Date is yet to announce. Hopefully it will be 3rd or 4th of Saturday. Like I said, it's a themed AI event. So whoever wish to take some session, you can nominate yourself. Okay, so if you have some interest, you can tell now itself so that I can contact. Any number of speakers are okay. So if it is 3 or 4, we will conduct here itself. Otherwise, we will make it a one big full day. That's it. Okay. Now about thanks. We have a near houseful event which is very successful now with 3 very interesting topics. So thank you all who came and made this successful. Thank you all the speakers. And thank you, Oran, for arranging the venue. We have one dedicated infrastructure person for recording. We recorded the session, so we'll be posting in KMUG group as well. KMUG, we have a channel, YouTube channel. We'll post there as well, and we got refreshments. We have notebooks and housekeeping staff who help. And there are few heroes who are not present here, like Rajneesh. And we have few core members as well who supported by creating the event pages, that meetup, maintenance, everything. So thanks to all of us, and hope to see next month again. Thank you. Yeah,